Hello there. In this lesson, we're going to learn a little bit more about distances in space, how far things are from each other, and the way in which we calculate and convert those distances. So first off, because things are so much bigger out in space, the distances and the sizes, oftentimes we'll use scientific notation to express these values because they end up being a little crazy with the number of zeros that you have. And so scientific notation is a good way to show that without taking up a massive amount of space. So our first big distance that we're going to use is the distance between the Earth and the Sun. It's an average distance because the orbit of the Earth around the Sun isn't a perfect circle. It's close, but it's not perfect. And so sometimes the Earth is a little bit further away and sometimes a little bit closer. But it's roughly 150 million kilometers to get to the Sun from here or vice versa. So to change that into a scientific notation, what you do is you move the decimal from the end of the number, where it usually is, until it's just one digit in, one non-zero digit in. So we're going to move this decimal 1, 2, 3, 4, 5, 6, 7, 8 spots, and that will be now scientific notation. So we say 1.5 times 10, and we moved it 8 spots. So that's scientific notation for that same distance. It saves you writing out a lot of zeros. Now, if it's a small number, you can do it as well. We'll have a look at how that works later on. So let's convert a few of these values into scientific notation. We don't have any units so far, but just the values. So we'll move this 1, 2, 3, 4, 5. So that's going to be 7.5 times 10 to the 5th. This one is a very small number, less than 1. And we're going to move this decimal 1, 2, 3, 4, 5 spots the other way. Again, you move it until it's just one non-zero digit in, right? So that's going to be 4.45 times 10 to the negative 5. So really small numbers, if you move in the decimal to the right, you'll get a negative value, and if you move it to the left, for big numbers, you get a positive value. So here's another big number. We're going to move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots. So this is 3.2 times 10 to the 10. Okay, now if you want to go the other way, you got to look at the number and move the decimal right or left. So this is a big number because it's a positive exponent here. So it's 743. What you do is you're going to move this decimal 7 spots. So that's 2 spots. Now you have to add 5 more zeros. So 1, 2, 3, 4, 5. And now you'll have the decimal number. This is a small number because you can see it has a negative value on the exponent. So that means we're going to take this decimal and move it that way, 8 spots. So you move it 1 spot till it's on the other side of the 5, and then 7 more zeros. So it's going to be 0.1, 2, 3, 4, 5, 6, 7, and then the 5, 2, 2 on the end there. All right, the last one is a big number again. We're going to take this decimal and move it that way, 5 spots. So 318 is, that's moved to 2 spots. So we're going to add 3 more zeros, and you have your value. Okay, on your calculator, scientific notation can be expressed pretty easily, depending on the type of calculator you have. Look out for a couple different signs. So some of these calculators make it really simple, and you get a nice value button there that does it for you. You push that EXP button, and then it'll put a exponent to the side, and sometimes they'll say times 10 here so that you know it's scientific notation. This one, sometimes it's a second function. Look for like 2 capital E's and EE. So you might have to use second function and get the EE. That's a little not quite as easy as the first one. But if I wanted to put in a value with in scientific notation, I would push, like say, 6.02, and then I would say second function, and then I would push that X button there with the EE on top. X something. I can't really see it. I covered up now. right? And so that there will give you times 10 to the, and then say I want the exponent to be 23. And then I would push 2, 3, right? It's the same with this calculator here. You can see the EE button there. So if I want to do that same number, I'd say 6.02, push the second, this guy here, and then I push the comma, which had the EE above it there, and then I push 23, and that would give me 6.02 times 10 to the 23. So this times 10 thing here, that's the EE value in both of these calculators, EE and EE. So have a look at your calculator, see what kind it is, and make sure that you can reliably use it to write out scientific notation. Okay, so back to our conversions. Obviously, kilometers and miles and units that we use for distance down here on Earth become kind of silly and teeny tiny out in space because the distances are just so much more mind-bogglingly huge than they are here. So within our solar system, a common unit to use is called astronomical units or AUs. And one astronomical unit is that distance between the Earth and the Sun, the average distance, right? So there it is, 1.5 times 10 to the 8 kilometers. So if you want to convert back and forth between those values, if you want to figure out like how many kilometers, say it's one astronomical unit, well, you multiply by 1.5 times 10 to the 8 kilometers per astronomical unit. And if you want to go the other way, if you have a whole bunch of kilometers, you want to change it to astronomical units, well, in that case, you're going to divide. So going this way, you're going to divide by 1.5 times 10 to the 8 kilometers per AU. So you use that same conversion every time. Either you're multiplying or dividing, depending on whether you're going to the bigger value or the smaller one. Okay, so let's try a few conversions using what we know already. So we got 0.53, so roughly half an AU, and we want to convert that into kilometers. So it's like halfway between here and the sun. And so if we have 0.53 AU and we want kilometers, we're going to multiply that by our conversion, which is 1.5 times 10 to the 8 kilometers for every 1 AU. So if you set it up like this, you can see that things cancel out. And so let's do that on my calculator here. So 0.53 times 1.5 times 10 to the 8th equals, and I get 795,000 kilometers. So try that on your calculator and see if you get the same thing. And now if you want to go the other way, if I have a whole bunch of kilometers here and I want to convert that into AU to make it a little more simple to be able to compare distances within our solar system, we'll start off again with what we're given here, 4.2 times 10 to the 9th. That's kilometers. And this time we're going to divide by 1.5 times 10 to the 8th kilometers for every AU. So you can see the kilometers cancel out. And I'll do that one on my calculator. 4.2 times 10 to the 9th divided by 1.5 times 10 to the 8th equals, and I get, ooh, bang on, look at that, 28 AU. So there you go. Hopefully you can use your calculator and get the same results. So really big distances, like between stars or galaxies in our universe, are even AUs is not a large enough unit of distance. So the one they most commonly use is called a light year. And so a light year sounds like time, but it's not. It's how far light goes in 1 year. And so this massive number, right? 9.46 times 10 to the 12th. So 946 and then 10 more zeros. That many kilometers is 1 light year. And so the distances out in space get to be just hard to comprehend for puny little ants like us on a tiny planet and the far end of one galaxy. And so to convert them, what we're going to do here is we're going to do the same multiplying and dividing. If you have a light year, you're going to multiply to get to kilometers. We're going to multiply by the 9.46 times 10 to the 12th kilometers in every light year. And if we're going to have kilometers and change it to light years are much bigger units, so we're going to divide by that same number, 9.46 times 10 to the 12th kilometers for a light year. Okay, so let's try a few of those conversions. Hopefully you're getting the hang of using your calculator. If I have 75.2 light years and I want to figure out how many kilometers that is, we're going to multiply by the 9.46 times 10 to the 12th kilometers in every 1 light year, right? And so if we do that, let's see what the old calculator says here, 75.2 times 9.46 times 10 to the 12 equals, whoa, that's a big number. So I got, I guess how many, we'll keep 3 digits, 7.11 times 10 to the, what's that, 14? Light isn't great here, kilometers. Wow, that's a lot of kilometers. Okay, and then going the other way, if we have 8.33 times 10 to the 14 kilometers, and we want to change that into light years, we are going to divide by 9.46 times 10 to the 12th kilometers in every light year, right? Kilometers will cancel out, and we'll get our light years. In the previous one here, the light years canceled out, and we ended up with kilometers. Great, so 8.33 times 10 to the power of 14 divided by 9.46 times 10 to the 12th equals, and I get 88.0. 88 point, I guess we could round that to 1, light years. There you go. Hope you can follow along with your calculator. All right, so the last thing here is just to consider an interesting fact about astronomy, and that is that when you're looking at objects that are so far away, the light has to take time to travel to us, to people on our observers here on Earth. And on the small scale, like small scale is the sun. The sun is a long way away. It's that 150 million kilometers, and it takes light about 8 minutes to get from the sun to us. So that means when you look at the sky, you look at the sun, you're seeing it how it was 8 minutes ago. That light left the sun and then came to our eye 8 minutes ago. When you're looking at stuff in your room, it's like instantaneous. It's so close because the light is almost instant to get from, like say, this monitor to your eye. But as the distances increase, so does the time it takes for the light to get there. This here is an image of the nearest star to us in our solar system, not our solar system, our galaxy. This is called Alpha Centauri, and it is 4 light years away. That means when you look at it through the telescope, you are seeing it how it was 4 years ago. That's the closest star, right? Here's the closest galaxy to us. It's called Andromeda, and it is 2.5 million light years away, which means when you see it, what you see, that's how it was 2.5 million years ago. We have no idea what it looks like now because the light hasn't gotten here yet. So that's a curiosity about space exploration and study that is a big part of everything that they do. All right, take care. We'll see you soon.